Hi, good afternoon, Dr. Rahman. And today I'm gonna present my research proposal presentation through this video. So my name is Lo Camping and my metric number is P103776. So this video is for the subject of RARA 6014. And let's start with my intro. So for my research proposal title is the synthesization and characterization for the optical properties of alpha and beta gallium oxide, which based on the thin film using the mixed-CVD technique. So this is the executive summary for this research proposal. And as we know that Lico, the Boyce Baudran, was the first scientist to discover the elements of the gallium. And gallium oxide is actually belongs to the conducting transparent semiconducting material. And it has polymorphs of the gallium oxide such as alpha, beta, gamma, delta, and also epsilon. So these five polymorphs both have their specific name, which is the alpha corundum, so beta monoclinic, gamma defective spinel, delta orthorhombic, and also epsilon orthorhombic structure. All of these polymorphs for the gallium oxide structure has an outstanding material which is suitable in applying in the power devices. So these power devices is actually to break down the high voltage and has better efficiency compared to the silicon carbonate and also the gallium nitride. Therefore, it has drawn a lot of attention from all over the world. The researcher currently mainly started to focus on this field is because they have seen the potential of the gallium oxide to be developed and also applied in the real life applications. So now comes to the problem statements. So however, for this material, they also have some disadvantages when producing during the experiment. So different conditions of the experiment will yield different kinds of polymorphs such as alpha, beta, gamma, delta, and epsilon gallium oxide. And one of the methods that I'm used is actually the mixed-CVD technique. They still have some flaws because the mixed-CVD is not actually consistent in obtaining the most stable state gallium oxide thin film structure. Actually, for the gallium oxide thin film, there is considered a metastable state. For this state, the gallium oxide is actually not stable enough to determine whether is it the alpha or beta. Therefore, we need to do the UEVs and also the XRD in order to determine the most specific polymorph at the end of the day. So all this gallium oxide structure is actually deposited on the sapphire substrate. So therefore, by adjusting the parameters, it can help to fix or overcome the fundamental limitation of the mixed-CVD technique. Therefore, we need to have a characterization and also optimization for this gallium oxide thin film structure. So the behind motivation for this project is actually to have a large investment and also knowledge base in order to tremendously applying in the conventional semiconductor devices technology. And the purpose is to develop a better sustainability in the mass production for new types of the semiconductor devices. And so next is the hypothesis. So as for the hypothesis, I have 2 points to mentioning, which is the X-ray diffraction and also the UV-Vis and near-infrared spectral range. So for the hypothesis that I can say that it's different kind of fabricating technique will affect the characterization of the gallium oxide thin film. So this is expect the linear optical functions of the thin film of the alpha and beta gallium oxide in the UV with near infrared spectral range. So it must be the linear kind of spectrum, linear kind of optical spectrum. And also the XRD is actually review nanocrystalline morphology with crystalline size with less than 10 nanometer for this gallium oxide thin film structure. And lastly, that actually want to mention is the accuracy of the data is actually really deduced from the layer model based analysis. So therefore, I'm using the Material Studio for the simulation. This is because when we are using the Material Studio, this can help to determine the model quality from the synthesis action of the gallium oxide thin film. So therefore, during the simulation, I'm also taking note with the accuracy of the sapphire substrate that deposited in order to produce a gallium oxide. So now comes to the research question. So I have 5 research questions in my mind. So the first one is how did the parameters affect the structure of gallium oxide after the end in the process? And the second one is how to get a stable state of the alpha gallium oxide and beta gallium oxide by using the MIS-CVD method. The third question is how to fabricate a alpha gallium oxide and beta gallium oxide structure in the most easily and convenient way. And the fourth question is what are the optimum parameters to achieve a better PL spectrum during the characterization. And lastly, the last research question is what is the best design parameters of the gallium oxide thin film structure in order to achieve a better performance efficiency compared to the other semiconductor devices. And now comes with the literature review. So as for the literature review, we all know that gallium oxide is actually belongs to the conducting transparent semiconducting material, and the first scientist to discover these new things is actually called the Boyce Baudran. He discovered the element of the gallium, and it also later on Roy has discovered the polymorphism of the gallium oxide in 1952, in the year of 1952. And this is definitely an outstanding material which can be applied in power devices and also in the microelectronics industry. So this polymorph can actually be either insulators or conductors. So it really depends on the growth conditions. So each of the polymorph will show their phases of gallium oxide under specific conditions. So I'm just taking 2 of the example, which is alpha gallium oxide is actually from the rhombohedral space group that synthesized from the gallium hydroxide between 450 degrees Celsius and 550 degrees Celsius. And as for the beta gallium oxide, it has a monoclinic structure that can be obtained by either baking other polymorphs of the gallium oxide in the air so that sufficient high temperature can be stored inside the furnace, and eventually it will synthesize the beta gallium oxide. So they also have a few things that I want to mention is for the alpha, beta, gamma, delta, and epsilon gallium oxide. So each of them has different ways to synthesizing it. So for the beta gallium oxide, they will be prepared by heating the nitrate, acetate, and also oxalate, or other organic derivatives which are above 1000 degrees Celsius. So another way to produce alpha gallium oxide is by preparing the heating of the beta gallium oxide at 65 kilobars at 1100 degrees Celsius. So after that, you need to decomposing the precipitate of the gallium hydroxide at 500 degrees Celsius. It will eventually producing the alpha gallium oxide. And as for the gamma gallium oxide, it was prepared by rapid heating of the hydroxide gel at 400 to 500 degrees Celsius. This method can produce more crystalline compared to the solvothermal synthesis method. And as for the delta gallium oxide, if you are continuous heating of the gallium nitride at 250 degrees Celsius, this polymer will eventually form. And lastly, for the epsilon gallium oxide, it prepared by the same heating sample from the delta gallium oxide, which is from the continuous heating of the gallium nitride. And for this literature review, the most important thing that I want to mention is the mixed CVD technique. The mixed CVD technique is what I'm currently using, and this is cost effective due to the simple setup apparatus, and it also consider a vast potential for the multi-wafer large scale growth apparatus for this mixed CVD technique. So this is the references that I'm currently referring for my research proposal works. And now comes to the research methodology. I have 3 stages of the research methodologies. So the first one is synthesizing gallium oxide by using the mixed CVD. So for this first method, I was deciding on the parameters such as the temperature, flow rate of the gas, the gases such as the argon and nitrogen when experimenting the mixed CVD method. So I'm trying to adjusting these 2 parameters, which is the temperature and also the flow rate of the gases for this first stage synthesizing of gallium oxide. And also for this first stage, I would like to characterizing different parameters of the sapphire substrate by either using PL measurement or UV-Vis in order to determine whether this product did it actually form at the end of the day. And for the second stage is the designing of new structure of gallium oxide thin film through the simulation process by using the Material Studio. So this stage does involve the design and optimization of gallium oxide thin film by using the Material Studio software. So the actual name is Material Studio 8.0. And after this simulation process, we need to study the optimized condition parameters of the gallium oxide thin film in this sapphire substrate. And this will be picked up as a suggestion in terms of the better performance efficiency during the final stage. So this simulation result will actually becoming my reference in future, so that I can refer it whether I'm in the correct path or not. So it's also important to have a simulation process. And lastly, for last stage of my experiment, last stage of the method that I'm using is optimizing and characterization of the gallium oxide thin film. So we have optical characterization and also the structural characterization. So firstly, I would do the structural characterization, which will be carried out on the gallium oxide structure by using the FANSAM, TEM, AFM, XRD, and also the UV-Vis. So the purpose is to observe the gallium oxide thin film structure without any significant lattice mismatch between gallium oxide and sapphire interface. And this structural analysis will be varies with different parameters. And lastly, for the PR measurement, we will be carried out in order to compare the emission of the gallium oxide thin film. So gallium oxide thin film here, and to compare with the UV-Vis result. So this is to confirm that the result does not doing wrong or having mistake by comparing from the result from the PR measurement and also the UV-Vis. So this is all the 3 stages for my research methodology. And I have 3 research objectives. So these 3 objectives is very important for me to conduct the experiment so that I would not going far or going out of the topic. So the first one is the enhance formation of the gallium oxide thin film by varying with the parameters when utilizing mid-CVD technique. And the second one is to investigate the structural properties of the gallium oxide thin film crystals when incorporated into the sapphire substrates. And lastly is the optimization. So this optimization will eventually study the condition of the gallium oxide structure during the simulation process. So thank you, and also giving my chance to listening my presentation video. And that's all.